Hi everyone, I am Dr. R. Soumya, Assistant Professor, Department of Electronics and Communication Engineering. The subject is Artificial Intelligence and Machine Learning. Unit 3 is the Supervised Learning. Here we are going to see the topic about probabilistic generative models. Generative models are a class of statistical model that generate the new data instance. These models are used in unsupervised machine learning to perform tasks such as probability and likelihood estimation, modeling data points, and distinguish between the classes using these probabilities. Generative models rely on the Bayes theorems to find the joint probability generative model, describe how data is generated using the probabilistic model. They predict P of y bar x, the probability of y given x, calculating the P of x comma y, the probability of y and x and y. Navier-Bayes. Navier-Bayes classification or the family of simple probabilistic classifier based on applying the Bayes theorem with strong independence assumptions between the features. It is highly scalable, requiring large amount of number of parameters linear in a number of variables in the learning problem. A Navier-Bayes classifier is a program which predicts the class value given a set of attributes. To know class values, calculate the probabilities for each attributes conditional on the class value. Use the product rule to obtain a joint conditional probability for the attributes. Use Bayes rule to derive conditional probabilities for the class variables. Once this has been done for all the class values, output the class with the highest probability. Navier-Bayes simplifies the classification of probabilities by assuming that the probability of each attributes belonging to a given class value is independent of all other attributes. This is a strong assumption but results in a fast and effective method. The probability of class value given a value of an attribute is called probability conditional probability. By multiplying the conditional probability together for each attribute for a given class value, we have probability of data instance belongs to that class. Conditional probability. Let A and B two events such that P of A, probability of A is greater than 0. We denote probability of B bar A, the probability of B given that A has occurred. Since A is known to have occurred, if becomes the new sample space replacing the original S. From this, the definition is P of B bar A equal to P of A into B and into P of A, or P of A and B equal to P of A into P of B bar A. The probability P of A bar B simplifies reflects the fact that the probability of event A may depend on the second event B. If A and B are mutual exclusive, then A and B and P of A bar B is equal to 0. Another way to look at the conditional probability formula is P of second bar first, that is equal to P of first choice and second choice into P of first choice. Conditional probability is defined quality and cannot be proven. Joint probability. Joint probability is the probability that measures the likelihood that two or more events will happen concurrently. If there are two independent events A and B, the probability that A and B will occur is found by multiplying the two probabilities. Thus, for two events A and B, the special rule for multiplication shown is P of A and B equal to P of A into P of B. The general rule of multiplication is used to find the joint probability that two events will occur. Symbolically, P of A and B equal to P of A into P of B bar A. The probability P of A and B is called joint probability for two events A and B which interest in the sample space. The Venn diagram will show that is P of A and B equal to P of A plus P of B minus P of A or B. Equivalently, P of A and B equal to P of A plus P of B minus P of A and B. It is less than or equal to P of A plus P of B. The probability of union of two events never exceeds the sum of the even probabilities. The tree diagram is very useful for portraying the conditional and joint probabilities. Next, let's see about the Bayes theorem. Bayes theorem is the method to revise the probability of an event given additional information. Bayes theorem calculates the conditional probability called a posterior or revised probability. Bayes theorem is a result of probability theory that relate the conditional probabilities. If consider A and B denote the two events, P of A and B denotes the conditional probability of occurring A occurring given that B occurs. The two conditional probabilities are P of A bar B and P of A and B in the general different. Bayes theorem gives the relation between the A and B and B and B. The important application of Bayes theorem is that it gives the rules how to update or revise the strength of the evidence-based belief in light of new evidence of posterior. There are two probabilities. One is a period probability is the initial probability value original obtained before any additional information is obtained. Posterior probability is the probability value that has been revised by using additional information that is later obtained.